So, hello students. Today we will learn the next part of about straight lines. So first we will start with understanding gradient of a line. So gradient is a property of a straight line. Basically, gradient gives you idea about inclination or inclination of the line with the x-axis. Mean like this. Okay, if this is the line, if I say this is my x-axis, correct? Gradient gives us idea about inclination. Like, see, this is line 1. Let us call this as L1. So inclination is this much. Inclination, this is L2. Okay, this is L2. And can I say L2 is more inclined with x-axis as compared to L1? So gradient means slope, and it gives us idea about inclination of your line with the x-axis, positive x-axis, by the way. Okay, so let us understand how to calculate gradient of any line. So here, let us say AB is a line here. AB is the line segment, by the way. Coordinate of point A is x1, y1, and coordinate of point B is x2, y2. Okay, so we have to calculate the gradient. By the way, if we try to calculate gradient, it gives you, it is the rate of change of, we can assume it as rate of change, rate of change, rate of change of y. At what rate your y is increasing with if I increase my x. So this can be equals to rate of change of y basically. Yeah, so this is change in y. You can calculate rate as change in y upon change in x. Okay, upon change in x. We can calculate it like this. So, okay, if I let us calculate gradient of AB. So let us write gradient is symbolically represented as m. The symbol m represent a gradient, and in the subscript I am writing AB. It means gradient of line AB. So to calculate gradient of line AB, you will have to understand what is change in y and what is change in x. So see, when I was at point A, my y coordinate is y1, and when I am at point B, my y coordinate is y2. So can I say my change in y is y2 minus y1? y2 minus y1. Okay, like see, if this point is P, let us assume this point is P. So if I try to get the coordinate of this point P, what will be the coordinate of this point P? See, the x coordinate of P and x coordinate of B will be same. Why? Because these 2 points are at the same distance from y-axis. Basically, your x coordinate is the distance of your point from y-axis. So, whatever this distance, the distance of B from y-axis is same as distance of B of point P from y-axis. So, its x coordinate of point P will be x2 only. Okay, what about y coordinate? To get y coordinate of point P, y coordinate gives us idea about height or distance from the x-axis. So can we say the distance of point A from x-axis, the height of point A from x-axis is same, will be same as distance of height of point P from x-axis? Yes, so since the point A is having y coordinate as y1, this one will also have a y coordinate as y1 only. Okay. Okay. Yeah. So it will have coordinate y1. And now very easily you can find if I ask change in y is nothing but distance BP. Change in y is nothing but distance BP, and that is y2 minus y1. Similarly, what is change in x? If I was initially I was at point A and then I reached at point B, what is my change in x? It is AP. Distance AP is the change in x. So that is x2 minus x1. Okay, x2 minus x1. So what we got here, we got a formula to calculate our gradient. Gradient of any line equals to y2 minus y1 upon x2 minus x1. Here one note point we will have to understand. See, here what we did subtracted y2 minus y1 upon x2 minus x1. You can do this way also, like y1 minus y2 upon x1 minus x2. The gradient you can also write, just note point the in whatever sequence we will subtract our y coordinate, in the same sequence you have to subtract x coordinate. That is not point. Anyway, so here we learned, we derived the formula of a gradient of any line, y2 minus y1 upon x2 minus x1. By the way, again, derivation is not required, but see, learning maths is all about enhancing your understanding. So that just for that sake, I have completed this way. The formula, knowing formula is quite sufficient right now. Let us see the situation where we will see some special situation. Like first situation is when line is inclining. Let us understand a line who is inclining. Like let us say like this. And what about inclining line? I think when I draw this way, this time my point A and point B, I think if this line is inclining, yes, you can say ki line AB is inclining. Line AB is inclining line. Okay. Inclining line means to the right your y coordinate will be more. If you move right, your y coordinate will be more. Okay, more y, if I move to the right, like since B is at the right of point A, so y coordinate will be more of point B. Okay, so here let us say we have to understand, let us say the coordinate, let us say I am assuming the coordinate of point A B, let us say 2 comma 4, suppose. So what about x? What about coordinate of point B? So if we try to calculate coordinate of point B, see B is to the right of A. B is to the right of A, and I think you understand it. Okay, if this is the x-axis, this is point A, and this is point B. Whose x coordinate will be more? If you move to the right, my x coordinate increases. So with this idea, can I write? Let us, so x coordinate of B will be quite more than x coordinate of point A. So let us assume it as suppose 3 only. And what about y coordinate? Definitely, since point B is above than point A, so y coordinate will be more. So let us assume 6. Okay. Right now number will not matter. I want to discuss something else. And in this case, if I calculate gradient, that is change in y upon change in x, correct? Change in y upon change in x, and that is change in y. So y2 minus y1, 6 minus 4. What? 6 minus 4. See, 6 minus 4 will be some positive, correct? What about um, change in x? Change in x is 3 minus 2. 3 will be more than 2, so it will also be a positive. And in that case, positive upon positive. So what is the note point? My final gradient, whatever gradient I will get, that will be a positive number. It means what we learned, what we can note from here, when your line is inclining line, your gradient will always be positive. Similarly, let us discuss this when line is declining. When line is declining like this, okay, declining line means if I move to the right, my y coordinate should decrease. Okay, let us say this is point A and this is point B. What about and the same coordinate, let coordinate of A be 2 comma 4. So what about coordinate of B? Since B is to the right of A, therefore x coordinate will be more. So let us assume 3. And what about y coordinate? Since B is to the down of A, so y coordinate will be less than point A. Let us assume it as 3. You can assume it anyway, anything. And in this case, if I try to calculate my gradient, it will be y2 change in y upon change in x, that is 3 minus 4. And when I do 3 minus 4, I will get some negative answer upon 3 minus 2, it is some positive. Okay, negative upon positive, your gradient will be negative only. Okay, what we learned. So when my line is declining, my gradient is negative. Okay, let us say this is also a quite important situation when your line is horizontal. So let us say a line be like this one. So this is point A, this is point B. Okay, horizontal line mean this is horizontal line mean. Okay, and let us say assume coordinate of point AB 2 comma 4, same way. What about point B? Since point B is to the right of A, so x coordinate will be more. Let us assume 3. What about y coordinate? We can clearly see the y coordinate of point B will be same as y coordinate of point A. Why that? Because B is at the same height of A. So the y coordinate will be only 4. And in this case, when I try to calculate my gradient, it will be change in y upon change in x, which is y2 minus y1. So 4 minus 4, that is 0, upon 3 minus 2, that is 1. Anything, let us say it is 0 upon 0 upon, I am writing it anything, because I am not concerned about anything. And I think we know 0 upon anything. If your numerator is 0 and denominator is anything, your final answer is 0 only. Okay, so what is that? If my line is horizontal, my gradient is 0. Okay, so we have three different cases. When your line is inclining, my gradient is positive. Okay, and y negative, it will be, when line is declining, gradient will be some negative. And when your line is horizontal, it will have a 0 gradient. Okay, let us say one more situation. When one more situation, and situation, let us write this way in blue only. Okay, for situation, let us understand this way. When a line is, vertical. Okay, when line is vertical, so let us say, okay, so this time our line is like this. Okay, this point and this point. Again, let the coordinate of point A be 2 comma 4. What about B? Coordinate of B, see, the x, since A and B are at the same, okay, B is not to the right or neither to the left, so x coordinate will be same. Yeah, so B, x coordinate will be 2 only. And what about y coordinate? Y coordinate will be more because B is above than A, so it will be 5 only. Let us say 5. And in this case, if I try to calculate our gradient, that is change in y upon change in x, 5 minus 4, that is 1, upon 2 minus 2 is 0. So your denominator will be 0. And do we know like how much? Anything upon 0, anything upon 0 is not defined. So my gradient at this time will be not defined. And I am writing ND in shortcut. ND means not defined. Gradient of a vertical line is not defined. We cannot define gradient of a vertical line. So these were 4 special cases. About inclining line, gradient will be positive. Declining line, your gradient will be negative. If your line is horizontal, gradient will be 0. And if your line is vertical, gradient will be not defined. This helps, this idea helps in plotting a line. This will help, and we will use this idea. Okay, and generally to calculate a gradient, if we have 2 point, we can calculate y2 minus y1 upon x2 minus x1 as the gradient. Let us take some questions based on this. Yes, so this is the question that we have. Okay. Let us take this one. So find out the gradient of the line. Okay. Now here, just a suggestion, always try to draw your line, because if we have visuals of whatever we are doing, understanding is quite easy. Let us say the point A, let the coordinate of point A be minus 2 comma 7, and coordinate of point B is 4 comma 5. Okay, so I think we know, and we have to calculate gradient of line AB. Correct. In the subscript, I am writing AB, so gradient of line AB equals to what? Y2 minus y1 upon x2 minus x1. Y2 minus y1 upon x2 minus x1. Now here, who is x1 y1 and who is x2 y2? See, you can consider anyone like A, and the point A as x1 y1 and B as x2 y2, or the reverse one. Just the note point, if I am subtracting, the direction should be same. If I subtracting y in this direction, my x, I will subtract my x in this direction also. Like, let me show you what I am saying. So y2 minus y1 is, I am subtracting in this direction. So 5 minus 7 I will do. 5 minus 7 upon x also I will do in the same direction. So 4 minus minus 2. 4 minus minus 2. Okay. So what is it all about? 5 minus 7 is minus 2 upon 4. Minus of minus 2 will be plus 2. So 4 plus 2 is 6. Is it how much? Minus 1 by 3. We got our gradient as minus 1 by 3. Okay, let us try to find the gradient of the same line but in opposite direction. Opposite direction means the same one but in this direction I will try to get. So in this time my gradient will be what? Change in y, 7 minus 5 upon, I will subtract x also in the same direction. So minus 2 minus 4. Yeah. 7 minus 5 is 2, and this is minus 6. 2 upon minus 6 is nothing but minus 1 by 3. Okay, what is the note point? The note point is our gradient, you keep your direction anyone, just the note point. Here also, see, my gradient was minus 3 also. A, if in what direction we will subtract y node point, in the same direction we have to subtract our x also. Let us take the next question. Okay, so next question is like this. The line joining this has a gradient. Okay, so that again I will draw the line. Let us say the line is like this. Let us say this is not the exact situation, but I am just trying to have a visual. 2 comma minus 5 and 4 comma a. Okay, this is the line. The gradient of line AB is equals to minus 1. In the question, they have given the gradient and we have to find A. The same thing, y2 minus y1. Let us subtract in this direction. So it will be A minus minus 5 upon how much? 4 minus 2 equals to minus 1, correct? So this is nothing but A plus 5, A plus of 5 upon how much? 4 minus 2 is 2 equals to minus 1. If I go this way, so it will be A plus 5, this 2 will go in product, so it will be minus 2. A plus 5 is minus 2, a equals to minus 2, and this 5 will go that side, so minus 2 minus 5, that is equals to a equals to minus 7, correct? A equals to minus 7. Yeah, that's it. We got the value of a. Just till now we have used just one formula of finding gradient. Thank you for this.